Okay, we're going to talk about midpoint and distance. Okay, first thing we're going to talk about is the midpoint. So we're going to use this little exploration. What are the coordinates of point M? What are they, y'all? Coordinates of point M. 1 what? 1/4. So write that down. 1/4. Follow along, guys. What are the coordinates of point T? 4, 1. Okay, now place the patty paper. I'm reading this box here. Place the patty paper on top of this grid, and then trace points M and T, and also connect them. Okay, so just place the paper on top, then drop that line, or just do the dots, and then connect them. Let's use the side of your notebook or something. You would probably be able to sketch it and still be pretty straight. Okay. All right, everybody got that dropped on their tracing paper? Okay, then it says, leaving the patty paper, draw a vertical dotted line through point M and through point T. So draw a vertical dotted line through point M and T. Vertical, remember, goes up and down. Sometimes you'll switch those up. Draw a vertical line like that. Keep it on your grid so that way you can use those vertical lines to help you draw straight. Draw it on the patty paper. Leaving the patty paper on the grid, draw vertical dotted lines through point M and through point T. Okay? Now it says lift the patty paper up so that you fold it and the dotted lines end up right on top of each other. Okay? So fold it so this ends up right on top of that one. And so you should get a fold somewhere down the middle, right? So if you fold that on top, your paper should be creased about right there, right? Yeah? Okay, so fold it, give you help. I'll come around and help you. You might have to hold the paper maybe up to the light so you can see that they fold and are landing right on top of each other. The two dotted lines should be right on top when you fold it. All right, now it says mark the intersection of that segment. Okay, so let's mark the intersection. So line is, so mark it where that crease cut, yeah, there you go, intersecting segment. NT. All right, let's go to number 1 now. It says you have formed separate segments by folding T. What do you observe about these two segments? Okay, so I'll highlight those in, I don't know, blue. So you have this one and this one. What do you notice about those two segments out there? There's the current, so write that down in number 1. Where they're the same size, okay, whatever you think. All right, number 2, in terms of distance, where is the intersection between the two dotted lines? Where is it? Right in the middle, okay, but it says in terms of distance. Okay, halfway. Halfway across. Yeah. Okay, so maybe like half the distance across. All Okay, get that counting paper again. Place it back on the grid. Make sure to line up your vertical tracings again. Line it up. Now this time, draw a horizontal dotted line through point M and draw a horizontal dotted line through point T. Okay, so let's go horizontal now. Draw a horizontal line through M and draw a horizontal line through T, and do the same thing that you did. Fold the horizontal line right on top of the other line. And then, so your crease should be in the middle, like right there. So fold it across, and so your crease should be somewhat in the middle. Okay, mark the middle again. Mark the middle where that crease touches that. So that's my spot right there. Mark that spot. So in terms of distance, where is this intersection now? Okay, half the distance again. Half the distance. Okay, and yes, happens to be the same one that we did with the verticals, right? So mark the point of intersection on that segment. Label it R. So that's I put mine in red. Label it R. Okay, and what's the coordinate of that point now? 2.5, 2.5. So write that down in this little box. 2.5, 2.5. 2.5, 2.5. Okay, so now if you were to fold it to where M ends up right on T, okay, you fold it like that, your crease now should be like this, okay? And so it still is right on that point, right? So that's now the midpoint of MT, okay? Which you probably figured out from the beginning, okay? So what's the relationship between for R compared to MT? That R is right in the middle of that segment. Good, write that down. Okay, so R is that midpoint of MT. So now let's figure out the formula. Okay, let's figure out the formula. What's the x coordinate of N now? Look at the what's the x coordinate of T? 4. If you found the halfway point between the two x coordinates, what x coordinate would be halfway? What's halfway between those two? 2.5. So you can just easily count, or what do you do with 1 and 4? Add them and divide by 2, right? What's the y coordinate of M? 4. What's the y coordinate of T, David? 1. Okay, if you found the halfway point between those two, what is it? 2.5. So now it says list the x and y coordinates of the halfway points we just found. What were they? 2.5, 2.5. How does this compare to the point of intersection we found on the planning paper? Same thing, right? So this point is called the midpoint. In your own words, what can you write down for the midpoint? It's exactly halfway. Okay, it's exactly half the distance between the two endpoints. Okay, if you write it in your own words, I'll write it in mine. so there's a formula right here that you can use to find the midpoint, which is kind of what we talked about with the x coordinates and the y coordinates. What do you think the formula is? How did we get this first one? Remember it was 2.5? How did we get that? X plus x, we did 1 plus 4, and then we divided by 2. So instead of writing x plus x, because we have to distinguish the two, how can we say x1 plus x2, and then we divide it by 2. That's how you get the first coordinate, okay? Find the first number of the coordinate. And then what's the second one? Very good. Okay, and then that's how we got the other 2.5. And so it works with any numbers, guys. Okay, so start this formula. You don't have to have it memorized. You can always give it off looking at this formula chart. Okay? So you can use this formula chart from here on out on any test or quiz. Right there on there. Okay, so this to me is the easy formula. Let's work with the more challenging one. Okay, a little bit more challenging. It deals with distance. Distance and length mean the same thing. So if I say, tell me the length of this segment in a coordinate grid, you will do what we discover here in a second. Okay? All right, so let's talk about distance. So we're doing S and Q. What are the coordinates of Q, y'all? 1. What's the coordinates of S? 4, 5. Okay, write those down. You can write it off to the side. I know the paper is kind of small. Okay, using a straight edge, connect the 2 points. Okay, if you want to just sketch it, you can. Just try to make sure you sketch it really straight. Then it says using the straight edge, draw the horizontal dotted line through Q. Okay, draw horizontal dotted line through Q. And then it says draw a dotted line vertically through point S. So draw vertical. What is the shape that you just created, guys? Right triangle. Write that in problem 1. Right, there's our right triangle right there. You can put the right angle in there also. Okay. What's the length of the horizontal side, y'all? 3. If you found the difference between the x values, okay, of coordinates Q and S, how does this relate to the horizontal side? So what are the x coordinates, y'all? For Q and 1 and 4, right? What's the difference between 1 and 4? What's that difference? 3, right? 4 minus 1 is 3, or negative 3. Okay, either way, it's 3 units. So how does that relate to that? It's the same. Okay, so all we do is take the x coordinates, x1 and x2. We found the difference of those. It's the same as that. Okay. What about the length of the vertical one? Well, how big is that one? That one's 4. Same thing there. How does that compare to the y coordinates? What were the y coordinates? 5 and 1. And so what's the difference between 5 and 1? 4 again. And so how does that relate? Same again. And so remember, 5 and 1 are like y1 and y2. Okay, so think about that, how it's going to come to the formula. All right, now it says use Pythagorean theorem to find the length of the third side. What's that third side called, by the way? Hypotenuse. We're going to find the length of the hypotenuse. And so I don't know if y'all remember from 8th grade, or maybe even 7th grade. Y'all do Pythagorean theorem? Oh, 6th grade. There you go. Okay. All right, so it's a squared plus b squared equals c squared. All right, these two sides right here, a and B represent the legs. Okay, I don't know if you all remember, we call the legs, the side next to the right angle, those are the legs. And then C is what, y'all? Okay, so we're getting that. Alright, so you just said that, what was the A? What was the length of A? 3, so we're going to write 3 squared plus 4 squared equals C squared. Okay, a lot of times you'll go and write a number here. Okay, that's not what I want. I want you to solve for it like an algebraic problem to where you can see by itself at the end. Okay, write this down. Okay, so what is this number on the left? We can probably do that all at once. What's that? 25. So all of that equals C squared. How do you get C by itself? Well, that's it. What? Square root it. Yeah, you don't want to square it again because then it'll become a 4. Okay? So don't square it again. We want to square root. Whatever you do to one side, you do to the other. Now it cancels out the square. We get C by itself, which is what we wanted. What's that? Perfect. So that's the length of that side. Okay? That's the length of that. So if you're ever given a coordinate grid, I would just make it into a right triangle because I have to here, right? I did that way back in 6th grade. Okay? So how does that tie into the formula? Okay, well, what represents the distance of the horizontal side? What did we do with those two x values? We subtracted them. So we write what? X1 minus x2. And then we square it, and then we take the square root like Pythagorean theorem does. And then how do we get the vertical distance? Y1 minus y2. Okay, that's your distance formula. Start that right there. You're going to have to use that. You won't have to memorize it. You just have to make sure you know how to use it. So let's practice using it on these next two. Okay. One partner, most y'all are sitting in partners. Okay, I'm not just pick one. One partner do number 7 and one partner do number 8. Okay. One partner do number 7, one partner do number 8. Okay, a good thing to do, guys, look, before you just start doing that, I would label one of them 1 and one of them 2. Remember how we wrote x1, y1? One's 1 point, the other one's the second point. Okay, and it doesn't matter. You can actually switch them up. You could do 2 first and 1 second. It doesn't matter. You're going to still get the same answer. All right, so y'all do that. And I'll do that up here. Don't look at mine. Try to do your own work. Alright, did the first person get 10 for the first one? Number 7. Second person, partner, number 8, you get 15. Okay, let me tell you the biggest mistake that a lot of people forget to do. Okay, because they're using their calculator. See this little part right here? They don't put the parentheses around that negative number, and then they leave their answer negative. Okay, right there. Then better on this one because the way I put it in there, it came out positive. right? If you don't put the parentheses, I'll put a little star next to that. If you don't put the parentheses, you're going to get it wrong, right? Think about it. If you're saying negative 6 squared, what does that really mean now? Negative 6 times negative 6. What's a negative times a negative? Positive. So anything that is squared, guys, anything that is squared is always going to come out positive. Okay? Yeah, you can reverse the numbers. But if you don't reverse the numbers to begin with, then you end up with negative values, and you need to just remember that it's going to come out positive. Okay? Or if you just, like she said, always remember, just keep it positive, even though it's technically negative. Okay? All right. Right, because anything squared is always positive. Okay, so then right here on the last one, I would solve this how, guys? Yeah, make the right triangle and just do Pythagorean theorem rather than insert it into the formula. I think doing Pythagorean theorem is a lot easier than doing the radical. Okay, that's maybe a lot more. All right, do that right now. So connected. Here's the horizontal distance and the vertical distance. What's the vertical distance, y'all? Or what's the horizontal distance? Okay, y'all get those numbers? If you didn't, then you're going to get the problem wrong. So make sure you count it good. Okay? All right, so now what do I write, guys? 4 squared plus 13 squared equals 3 squared. Somebody know what 4 squared and 13 squared is? What if those two added up? What's the last step? Square root. That gets rid of that. So C equals, that's not a perfect square. I know for a fact. Okay, so turn it into a decimal. So somebody out there calculator. 13 by what? The income. Yeah, so round to at least 3 decimal places. 0.01. Okay, so roughly that's the distance between the